Alright guys, welcome to this video, and this video is gonna be interesting because in this video I'm gonna show you how the Tower of Hanoi works, how a recursion works in Tower of Hanoi. I've seen many students who just memorize the code. Well. It doesn't work in that way. We coders, we don't memorize the things. We understand the concept and then we implement it in our code, right? So we will see how recursion works in the Tower of Hanoi, and then we will implement that in our VS Code. And by the end of the video, I'm pretty damn sure like you won't be memorizing it anymore. You will really understand the steps because I'm gonna show you visually how to solve this puzzle. Okay, so with that said, let us see the pseudocode to solve the Tower of Hanoi. All right, so I'm gonna delete this piece from here, and then let me write the pseudocode to solve this problem. uh, we are gonna create a function. Let me name it as Tower of Hanoi, TOH with N, and then we have a source and an auxiliary and a destination. Well, if you have not subscribed to my channel, consider subscribing it, and I will be bringing in more interesting videos and tutorials, and I would really appreciate that. All right. Okay. Now let me see. Let me show you actually how what exactly Tower of Hanoi is. We have three rods. Let me call it as source. Okay. Source and auxiliary and destination, if I spell it right. Okay, here. So I do have three disks here, and we need to transfer all the disks from source to destination in the order that it was in source, right? And while transferring all the disks from source to destination, we need to follow some constraints, right? So the first constraint will be we can just move one disk at a time, right? And the next one would be we cannot place a larger disk on top of a smaller disk. So by not violating these two rules, let me write it here, the rules that needs to be followed. So without violating these two rules, we need to transfer the disks from source to destination. And I'm going to show you visually how to solve it with recursion. Okay, so I hope this logic is clear, because in the end of the video, I will show you the steps, and you can really understand it. So till then, just bear with me. Let me write the pseudocode so that I can explain you through the code. Fine. So for recursion, as we know, we need a base case, and for this one, what I would say is that when n is equal to 1, just print disk 1 move from source to destination. Okay, so this is my base case to stop the recursion. Now here comes the fun part. I'm gonna call the same function again, but with a step backward. I mean with a number lesser than n, with one step backward. Fine. And here what I'm gonna do is I'm gonna swap the place. I'm gonna swap the place of auxiliary and destination. I'm gonna keep the source same. I'm gonna change the auxiliary to destination, and then I will have the auxiliary here. Okay, and then I would say print disk n move from source to destination. Okay, and then I'm gonna call the function again, and I would say I would swap the place of the source and destination. I will have the destination here, we'll have the source here, and the auxiliary here. Fine. Okay, so this is where the main logic is. Okay, we need to understand the code. uh, you need to focus here, you need to concentrate, you need to understand it, the steps, because this is the most important part, right? So what I would do is, I will just, place this somewhere. I don't have any space here to write. Just drag it here to the corner. If you want, you can just take a pen and paper and then just write down the pseudocode so that you can match with me, uh, and you understand the things. Okay, so if you want, you can pause the video and then just write down the steps that I wrote here, and then just the way I move the disk, you can tally it from the pseudocode. Okay, so with that, I'm gonna call, the function has been created, and I'm gonna call TOH with 3, where in TOH, the number of disks I say is 3, and A, B, and C. In fact, what I would do is I would just say your source, destination. I'm sorry, that would not be destination. I have the auxiliary here, and then destination. And how I'm gonna call is, I will say TOH 3, and I would have the source here as A, auxiliary as B, and destination as C. Okay, so my first call, I'm calling with 3. So what's gonna happen is, it will write here in memory. Okay, it will be like 3, A, B, and C, which would gonna call the same function again with 2, A, C, P. You see here I had swapped the, the destination and the auxiliary, I swapped it. So here it is. And then what I say, print disk n. So what is the value of n here? It is 3. So print disk 3, move from source to destination. So what is my source here? Source is A and destination is C. Okay, and then Tower of Hanoi 2, I'm gonna swap the source and the auxiliary, so that would be B, A, C. Fine. So this is in the box when the Tower of Hanoi was called with the number 3. Okay, this isn't executing yet. It will be in memory, but this line will get executed, and here the value of n is right now, let me write down here 2, A, C, B. So what's my source here? My source here is A, auxiliary is C, and destination is B. Fine. So when this is called, my function would be Tower of Hanoi with 1. I'm gonna swap the auxiliary and the destination, so it's gonna be A, B, C, right? And then I would say print disk 2, moved from source to destination. So what's my source here? It's A to B, right? And then once again I'm calling the function with 1, and this time I'm gonna swap the source and the auxiliary, so that's gonna be C, A, and B. So once again it will try to enter this function, but when it goes, okay, when it goes, what was my base case here? Say if you can see it, if n is equal to 1, you say print disk 1, move from source to destination, right? So when this is called, let me grab my pen. when this is called, my source is A and destination is C, right? So I don't have space here to write. I will write it here in a short form. Okay, I would say 1 from A to C, right? Great. So my this part is done. Okay, now it's gonna print disk 2 move from A to B. Okay, so let me do that. 2 move from A to B. Okay, this is 2. All right, so this is done. And then again, it's gonna go again and say TOF with H. I'm sorry, TOH with 1 CAB. So what's my source here? My source here is C. My destination is B, right? So I'm gonna write the same. It would be 1 move from C to B. Okay, right? So this is done. I'm gonna delete this. All right, let me keep that there. So this is finished. I'm gonna remove it from the stack. It's done. Now what do I have? We already did this part, so I'm left with this one. So let me do that. So that would be 3 move from A to C, right? I'm done. Now once again, I see here TOH 2 B and C. So I'm gonna enter this function, and then I would write TOH 2 B A C. So what my source here? What's my source here? My source here is BAC. So my recursive call would be 1, and I'm gonna swap the auxiliary and the destination first. So that's gonna be B C A, right? And then I'm gonna say move 2 from, what's my source here? My source here is B to C. And then I would say TOH 1. I'm gonna swap what? I'm gonna swap the source and the auxiliary here. Okay, so that would be A B C. Now I would enter this part, and this is the base case. So since I do have left with just one disk, so what I'm gonna do is I would write here move the disk 1, move from B to A. All right, so this is done. I'm gonna execute this. 2 from B to C, right? This is done. I'm gonna check this. 1 move from source to destination, that would be A to C, right? So I'm done with this. Okay, so let me remove this from the memory of the computer. Okay. It's popped out, and resulting in this task is also done. So since this is done, I'm gonna remove this from the memory. So my all tasks has been done. Let me bring this up. Let me bring this up. And now let's see if our all moves, I mean all the disks has been moved from A to C just by following the steps here. Okay, so I had what? I had A, B, and C. So the first part was moved. This one which I had was 1, 2, and 3. The one has been moved from A to C. So my step would be 2, 3, A, B, and C. And I move one from A to C. My this part is done. Now I'm on the second line which says 2 from A to B. Okay, so let me do that. 2 from A to B. Okay, which brings me here. Now I say 1 from C to B. Okay, let me do that. I'm done with this. I'm done with this. And now I say 3 from A to C. Okay, let me do that. 1 from B to A. Let me do that. 2 from B to C. Let me do that. Okay, yeah, 1 second. I'm done. And finally, I have here 1 from A to C. Let me do that. So now you can see that from rod A, my all the disks has been transferred to rod C. The order it was in A, the same order it's in C, right? So now let's go ahead and check in VS Code. How does it work, right? So here we are in a VS Code, and let's write the code real quick. If I can get the right place. Okay. Mm, I do have a boiler code here. Okay. And then I'm gonna write the function, and I would say TOH, which is gonna take the number of disks and source, auxiliary, and destination. Fine. So I'm gonna call this function TOH, and I would pass in 3. My source would be A, auxiliary would be B, and destination would be C. Right, now let's build the logic here, and I would say if n is double equals 1, printf move disk 1 from %C to %C, which is source and destination. Right, now I'm gonna call TOH with n minus 1, and then I would swap the destination and the source. I would say, sorry, destination and the auxiliary. I would say source, comma, destination, comma, auxiliary, and I would print. Just copy it from here. But here, instead of 1, I would say %C, and here this would be that would be D, and this would be N. And I would just copy this, and I'm gonna swap. I'm gonna swap here. I'm gonna say your aux source and destination. Right, so our code is done, and here I am gonna say return. Now let's compile it. GCC Tower of Hanoi Tower of Hanoi, chmod +X, Tower of Hanoi, and clear the screen. Tower of Hanoi. Ah, I have to give a new line here and here. All right, perfect. Compile it, permission, and run it. So you can see here the disk one has been moved from, I mean, if you just write on it, you're gonna get the same result. All right. So that's it for this video. If you have liked this video and if you've understood this, don't forget to hit the like button and share with your friends. All right. See you in my next video. Till then, take care.